Welcome to the 41 session of LMS. This program is for BSc students subject mathematics for 5th semester. Title of the paper is Numerical Analysis. So we are studying about the finite difference, which is the third unit of a numerical analysis paper. In that today we are going to solve some of the problems. So recap, as we have read in the last classes how to solve the problems related to the difference table. At the end of this session we can able to solve the problems which are related to the last sessions, that is I can say delta, forward difference del. So first problem here, we have to show that y of 3 is equals to y of 0 plus 3 times of del of y0 plus 3 times of delta square of y0 plus delta cube of y0. So here, what is this y of 3? Please remember here, y of 3 is a value of the y at x is equals to 3. When x is 3, its value, like that we are going to write it is. In some textbooks they are using u3, u4 like that. That is, it is nothing but an y of x in general, I can say. Right friends? So y of 3 is equals to, so we have to do this. Now we have, I have considered it first, that is I will consider one by one term. That is, first we will take delta cube, then we will take delta square, then we will find delta. All these values we will find first, okay? So I have considered this delta cube of y naught. So what do you mean by delta here? Delta is nothing but an e minus 1. There is a relation, we have proved that, right? Delta is equals to e minus 1, so I have substituted that. Delta means e minus 1, whole cube we have kept as it is, and y naught. Now this is nothing but a formula of e minus 1 whole cube formula. Now if you apply e minus 1 whole cube formula, what will be the terms? We will get all this terms. There is e cube minus 2 times of e square plus 3e minus 1, and I have kept this y naught as it is. Now I will multiply this with e cube, that is I will write it here. I will write it here, that is e cube into y naught. If you multiply this first term, right? So similarly minus e times of e square y naught. Okay, so if you see these terms, how it will looks, this is nothing but an e to the power of n into f of x, e power n into f of x, right? So what is the formula for this? It is nothing but an f of x plus n h, right friends? This is the formula, so we will use this formula. What happens here? X plus nh, h is equals to 1 as usually we will take it. So it is e to the power of 3 times of y naught. So we can write this as y of 0 plus 3. This is equals to y of 3. Right? This is 0. So this is the way I am writing it here. You can see this. Right? So we can write this. So if you multiply this all the terms, you will get it. So this is e cube of y naught, it will becomes y3. Similarly 3 times of e square y naught, we can write it as 3 times of y of 0 plus 2. So it will becomes 3 times of y2. You can see here it is, term is here. Similarly if we come across this term, it is now, it will become, after multiplying, it will become like this, right? 3 into e into y naught, so it will become 3 times of y0 plus e power 1, so 3 times of y1 it will becomes, that it is here, right? Similarly, here is, if you multiply this and this term, that is last term 1 into y naught, so we have wrote it here, right friends? So in this way I can expand this especially this term. Now we have got this one, y3 minus 3 times of y2 plus 3 times of y1 minus y naught. Now what I will do, I will take this term. Now you can see it here. I will consider these terms, 3 delta square of y naught. Okay, now I will solve this. Similar method I will apply as in the last. So what is this delta means? Delta means e minus 1. We have substituted that. So whole square as it is y naught. What is this e minus 1 whole square? It will looks like a minus b whole square. A square plus b square. A square minus b square. A square plus b square minus 2ab formula we will apply it. So we can, now what I will do, I will multiply these terms. Now I will multiply the terms, these terms, all the terms, this all terms I will multiply it. This into this, it will be e square y naught, right? So if you again apply e to the power of n of f of x, then it will be y of 0 plus 2, so it is y2, right? Similarly, if you multiply this and this and this and this, I will multiply all the terms. What happens? What we can get, you can see it here. If you multiply that with the 3, I am multiplying. So if you y naught, here 3 should be, here it is 3 is there, right? So it is 3 times of y2. You can see 3 times of y2. Similarly, this is e of y naught, it will become y1 plus y naught as it is, and I will multiply this 3, so this is the term I will get it, right friends? These terms I will get it. These are the terms that we are getting. Now, so I have kept this term as it is here. Now I will consider another part, that is delta of y naught I will consider. Now I am considering here delta of y naught, 3 terms of delta of y naught. Delta means e minus 1, right? I wrote here is y naught. Now I will multiply this one, e into y naught, y1, right? And 1 into y naught, as it is 3 is multiplied, so after simplifying I will get this answer, right? Now I will substitute all the values, that is whichever I have found it. I have got the value of this one, this I will substitute it. Now you can see delta cube of y naught is this terms, right? Total 4 terms are there. I will show you that 4 terms I have wrote it here. Here are the 4 terms, you can see it here. This is first term, that is delta cube of y naught value I have substituted. After that I have substituted this delta of 3 times of delta square of y naught I have substituted it. Here it is, that values are here, you can see it here very clearly. I substituted it, okay, up to y naught. These are the values. Then I substituted 3 times of delta square value. 2 terms are there. Just I have substituted it, right? And lastly y naught. This y naught is here, right? This is y naught. Now I have substituted all the value. If you simplify this, all the values, if you simplify this all the values, we will get it as y3. My answer is y3. Right, friends? Now we'll go for the next problem. We have to show that delta cube of y0 is equals to these terms. Okay. Now solution. We will consider this LHS. Delta cube of y0 is equals to. So this is here. Now here, what is this delta? E minus 1. That is, we know that delta is equals to E minus 1 is a relation is there. We have substituted that. Now A minus B whole cube formula I will apply. We will get these terms, and y0 is as it is. Now I will multiply this with here. It will becomes E cube y0. I will write it once again. It will become E cube times of y0. Right, friends? This is nothing but an e to the power of n of f of x. So what will be, if you simplify this, it will become y0 plus 3. So it is y3 it will becomes. Like this, I have simplified the terms. This term I have simplified it first. Okay, this into this. Now next this into this. What happens? This is 3 times of this e square is there, y0 is there. If you y2 it will become. Similarly, this into this e power 1 is there, so it will become y1. Similarly, this is multiplying y0 it will becomes, right? So I have got this. You can check that. Simply we have proved it. Now I'll consider next problem. Evaluate delta of 2 to the power of x divided by x factorial. Here wherever h is there, we will substitute it as a h is equals to 1. Right? We will erase all the terms. So now you can see, to evaluate this third problem, I will consider this one first. Delta into x to the power of 2 to the power of x divided by x factorial. So this delta is applied. What is this delta? Delta is nothing but, and I know that it is a forward difference, right? So first what we will do it, we will apply the forward difference. What does the forward difference says? If it is a f of x is there, delta of f of x is there, then what I can do it? It is f of x plus h minus f of x. Right? I have done it here. Same formula I have applied it. You can check it out here. So this is f of x, that is 2 divided by 2 to the power of x divided by x factorial by f of x, right? So wherever x is that, it should be replaced by x plus 1. Why? Here h means 1. We have done 2 to the power of x is there. X means what I can say, this is x plus 1. Here it is x plus 1. You can see these terms, right? X plus 1 we have wrote, right? Here we have wrote it, this term. Now here x is there, I have to replace by x plus 1. We have replaced it. Similarly, f of x is written as it is, right? So now next, in the next step, we will just split the numerators. You can see it here. It is 2 to the power of x plus 1 is there. I can write it as 2 to the power of x into 2. Bases are same, add the powers, that policy. Okay. And in denominator, x factorial, it can be written as, you can see it here. Here x factorial is here. In the denominator, second term, it is x plus 1 factorial. Here x plus 1 factorial can be written as x plus 1 into x factorial, and this term kept as it is. Now what we can do in this overall, I can take 2 to the power of x in the numerator common and x factorial in the denominator. I have taken it, so it will become 1. We have wrote it here, minus is there. Here left out 2 divided by x plus 1. We have wrote it here. Now in this part, we will take x plus 1 as a LCM. If you take this and simplify, x2 minus x minus 1 will be there in the numerator, and x plus 1. So if you simplify this, 2 minus 1, it will become 1. So in the numerator it is 1 minus x, and it is 2 power x as it is, and this one is written here, x plus 1 into x factorial. Now this is my final answer, I can say, but still simplified. This, what is this in the denominator? If you see this denominator here, this term, it is nothing but an x plus 1 factorial. So we have wrote that. So these are the some of the problems we have solved. Now these are the some of the books for your references. G.K. Ranganathan, Dr. Mante Swami, Prabhakar, Shant, Tukumar, right? So thank you, friends.